Are you trying to get into making your own Arduino projects? Here's a simple reaction time game that you can make yourself in just 15 minutes. In the game, one random LED out of 3 will light up. Press the corresponding button in the row as fast as you can and the serial monitor will tell you how long it took for you to react. To build this, you'll need 3 LEDs, 3 buttons, a handful of jumper wires, 3 220 ohm resistors, 3 10K ohm resistors, an Arduino, a breadboard, and a programming cable. To start, place down 3 LEDs of any color next to each other on the breadboard. Similarly, place 3 buttons down on the other side of the breadboard like so. Now, connect your 3 220 ohm resistors to the longer leg of each LED to prevent them from getting burnt from the current. Now, connect each resistor to pins on your Arduino with jumper wires like this. The LEDs will be outputs, so the voltage will come from these pins. I used pins 11, 12, and 13. On the other side of the LED, connect it to the ground using a jumper wire. Make sure the shorter leg of the LED is the one leading to the ground. Use another wire to connect the negative strip of your breadboard to the ground pin of your Arduino. Now we'll handle the buttons. Connect the 5-volt pin of your Arduino to the positive strip of your breadboard like this. Now, use jumper wires to connect the voltage to each button. On the other side of your button, connect the opposing half of the button to pins on your Arduino like this. I used pins 2, 3, and 4. However, now we need to fix a possible issue. When the button's not pressed, our input pin becomes a floating input. This means that any electrical noise from your environment can cause a false positive on our code, as it only responds to either no voltage or any voltage from our input. There are multiple ways you could fix this. I chose to add a 10K ohm resistor to the row that our button attaches to and connect it to the ground like this. This is called a pull-down resistor and establishes a connection to the ground for our input. Finally, double check that all wires are connected to correct rows and each element has a full circuit connected to them between the power and the ground. At this point, your wiring should look like this. Finally, it's time to code. Open Arduino IDE and connect to your Arduino. First, define each pin number for your LEDs and buttons. This will make the code easier to write and follow. In the setup, we'll start our serial communication. This is where we'll see our reaction times. Then, we'll define our button pins as inputs and our LED pins as outputs. Remember that electrical noise from our environment from earlier? We're going to use that to our advantage in generating us a random selection of LEDs for our game. We'll do this by using an empty analog pin, allowing us to get a reading that changes every time we use it. This will give us a random seed and thus a random set of numbers every time we use it. If we did not generate this random seed, then the same sequence of LEDs would light up from each time we ran our code due to how C++ chooses random numbers. Now that we're past the setup, we'll write the loop code. First, we needed to turn off all the LEDs to start the game. Have the code wait a random time before lighting up the first LED, so that way it doesn't light up immediately. Now, set each LED to integers 1, 2, and 3 and have our code select one of those 3 numbers. We'll have that random selected LED turn on. Additionally, at this point, we'll have a start timer to mark the exact millisecond when the LED lit up. We'll subtract this from the total time that the program has been running in order to obtain our reaction time. Now we'll have the code wait for the button to be pressed. If the correct button is pressed, subtract the start time from the total runtime to get the reaction time. Else, it'll tell you that you pressed the wrong button. Finally, give a small delay before repeating the program once again. Our code is now finished. Try out the game for yourself and see what time you can get. Check your reaction time by opening the serial monitor on the IDE. This project is especially easy to add onto and turn into your own unique build. You could add an LCD screen, a buzzer, or more to really flesh out the game. What would you add?